This video aims at the talented and gifted students. I will cover major mathematical skills and techniques for doing arithmetic in Mathematics Olympiad for primary school students. I assume all these warm-up exercises will be easy for you. You may pause the video at any time and work on these questions. In this video, I will explain all the questions here. So I will go through associative property, commutative property, as well as distributive property. Associative properties in addition is simple. Say for example, when we do 2 plus 3 plus 4, you can add 2 plus 3 first, or you can add 3 plus 4 first. At the end, you will get the same result. This is also the same for multiplication. Say if you are asked to find the product of 2 times 3 times 4, it doesn't matter that you start with 2 times 3 or 3 times 4. At the end, you will get the same result. So what is commutative property? Commutative properties means you can interchange the number and then you get the same result. Say in addition, you can do 2 plus 3, which is the same as 3 plus 2. In multiplication, you can do 2 times 3, which is the same as 3 times 2. But you can't do it in subtraction. Say 3 minus 2 is not the same as 2 minus 3. You cannot do it in division as well. The last property I will explain is the distributive property, which we will see in a lot of examples. It sounds that it is a very simple property, but it is very powerful. So 2 times bracket 1 plus 3. Usually we will do the bracket first, but sometimes we would like to expand the bracket. So this one becomes 2 times 1 plus 2 times 3. Sometimes we may not expand the bracket. You can see something like this, and then you group them together and you write it in this way. This is what we call factorization. So right now I will start with the first examples, which makes use of group of tens or multiple of tens. We'll work on 7 questions, and we'll write numbers in a form which involves multiples of tens or hundreds. So we will start with question number 1. Evaluate 796 plus 513. So we are going to write 796 into 800 minus 4. And then we add 500 and plus 13. So we have 800 plus 500, which is 1,300. And we have 13 minus 4, which is 9. So the answer is 1,309. You may need to pay attention that minus 4 plus 13 is the same as 13 minus 4 due to the commutative properties of addition. Question number 2. Evaluate 347 minus 169. So when we work on these questions, I'm going to break down minus 169 into minus 147 and then minus 22. The reason that I choose minus 147 is because I wanted to cancel out 47 in 347. So right now I have 347 minus 147. So I have 200 minus 22, which is 178. Question 3. Evaluate 398 plus 417 plus 296 minus 202. So I'm going to write 398 into 400 minus 2, and then plus 400, then plus 17, and then plus 300 minus 4, and then a minus 200 minus 2. So the answer is 400 plus 400 plus 300 minus 200, which is 900. And then I have 17 minus 2 minus 4 minus 2, which is plus 9. So the answer is 909. Question 4. Evaluate 297 plus 295 minus 103 minus 98. So right now, I think you know how to break down all these numbers. 297 would be 300 minus 3. 295 would be 300 minus 5. Minus 103 would be minus 100 first and then minus 3. Minus 98 would be minus 100 plus 2. So the answer is 300 plus 300 minus 100, which is 400. And then minus 3, minus 5, minus 3 plus 2, which is minus 9. So the answer is 400 minus 9, which is 391. Question 5. Evaluate 136 plus 359 plus 364 plus 241. We're going to group numbers which can form hundreds. So we swap these two numbers, then we have 136 plus 364. The reason is these two numbers, when they group together, it gives you 500. And then we add 359 plus 241. These two numbers, when they group together, they can form 600. So we can have 1100. Question 6. Evaluate 162 plus 427 plus 338. Similar to the previous questions, we will group 162 and 338 together. Because these two numbers, when they add up, they form 500. So 500 at 427 gives us 927. Question 7. Evaluate 357 plus 237 plus 743 plus 63. Similar to the previous examples, I will group these two numbers together. So 357 plus 743 gives us 1100. And 237 plus 63 gives us 300. So adding up, I have 1400. So in these 7 examples, I have used commutative laws in addition, as well as groups of tens or multiple of tens. In the next slide, I will use commutative laws in multiplication. I will also form groups of tens or hundreds in multiplication. In this slide, we work on 4 questions on multiplications. Question 1. Evaluate 9 times 4 times 25. So, we will not do 9 times 4 first, because it will give us 36 and then we need to multiply 36 by 25, which is a bit clumsy. So what we're going to do is we will multiply 4 by 25 first, and then we multiply by 9. So this makes use of the associative law in multiplication. So 4 times 25 is 100. 9 times 100 is 900. Question 2. Evaluate 125 times 431 times 8. So we are not going to multiply 125 by 431 because it would be difficult. So what I'm going to do is I'm going to swap these two numbers. So this makes use of the commutative law in multiplication. So 125 times 8 is 1000. 1000 multiplied by 431 is 431,000. Question 3. Evaluate 125 times 48. So I know that 125 times 8 would give me 1000. And I know that there is an 8 in 48. So what I'm going to do is I'm going to split 48 into 8 times 6. Then I will have 125 times 8, which gives me 1000. And 1000 times 6 is 6000. Question 4. Evaluate 25 times 125 times 32. So I will break down 32 into 4 times 8. Because I know that 4 times 25 gives me 100. And 125 times 8 gives me 1000. So 100 times 1000 is 100,000. To summarize, I have used associative law and commutative law in multiplication. I have also multiplied numbers which will form hundreds and thousands together. So we are asked to evaluate 1999 plus 999 times 999. The first thing that I'm going to do is I'm going to break down 1999 into 1000 plus 999. And then I realized that this 999 is actually 999 times 1. So right now here, 999 times 1 plus 999 times 999. So how many 999 I have right now? The answer is 1000. And here I also change 1000 into 1000 times 1. So right now I have 1000 times 1 plus 1999. And how many 1000s I have right now? I have 1000s, and the answer is 1 million. This question makes use of the distributive law, and I have used it 2 times. So this is the first time I use it when I grouped these two terms into 1000 times 999. And the second time I use it is here when I group these two terms into 1000 times 1000. In this slide, we are asked to evaluate 99,999 times 77,778 plus 33,333 times 66,666. Since I want to use distributive law, so I see that here I have 99,999, and I also want a 99,999 here. And I can see that there is a 33,333. So if I can take out a 3 from here, then it would be great. So the first thing that I'm going to do is I'm going to break down 66,666 into 3 times 22,222. Then, when I multiply these two numbers, I will have 99,999. I can use distributive law right now. So, how many 99,999 I have? The answer is I only need to add these two numbers up. So adding these two numbers gives me 100,000. The answer is 9,999,900,000. We are asked to evaluate 2021, 2022 times 2022, 2021 minus 2021, 2021 times 2022, 2022. The first step is I want to change this into something which is similar to this one. So first of all, I will change this 2021, 2022 into 2021, 2021 by writing it as 2021, 2021 plus 1. And then I keep the remaining the same. Then I will apply distributive law. So I will expand this bracket, which means that I have 2021, 2021 times 2022, 2021 plus 1 times 2022, 2021, and then minus the same thing. Then right now I got this term, 2021, 2021 times 2022, 2021, which is not exactly the same as this one. So what I'm going to do is I'm going to change this term into something which looks like this one. So the next step is I change 2022, 2021 into 2022, 2022 minus 1, and I kept the remaining the same. So I applied distributive law again. So I multiplied these two terms and then subtract 1 times this term, and I keep the remaining the same. Then right now I realize that these two terms are the same, so they can cancel out each other. So I have 2022, 2021 minus 2021, 2021, which is 10,000. In this example, we will evaluate 1 times 2 plus 2 times 3 plus 3 times 4 and so on, plus 98 times 99 plus 99 times 100. So this is what we call a series. A series is the sum of a sequence. So all these numbers here formed a sequence, and we add them up together. In order to evaluate this expression, we're going to multiply each term by 3. That means I'm going to multiply this term by 3, this term by 3, this term by 3, and so on. You will know the reasons why I do so very soon. So the first term, 1 times 2 times 3, is still 1 times 2 times 3. And for the second term, 2 times 3, I multiply by a 3. For this 3, I will change it to 4 minus 1. And then I would have 2 times 3 times 4 minus 1 times 2 times 3 by the distributive law. For the third term, 3 times 4, I will also multiply it by a 3, and I will change this 3 into 5 minus 2. And then I will apply the distributive law. Then I have 3 times 4 times 5 minus 2 times 3 times 4, and so on. So for the last second term, 98 times 99, I will also multiply it by a 3, and I'll change the 3 into 100 minus 97. By the distributive law, I have 98 times 99 times 100 minus 97 times 98 times 99. For the last term, 99 times 100, I will also multiply it by a 3. Then I will have 99 times 100 times 101 minus 98 times 99 times 100. We are asked to evaluate this expression, and we multiply each term by 3. So end up we are having these terms. And what I'm going to do is, I'm going to add all these terms up, and I will divide the answer by 3. So we see that here I have 1 times 2 times 3, and I also have minus 1 times 2 times 3. So these two terms can be cancelled out. I have 2 times 3 times 4. I also have minus 2 times 3 times 4. These two terms can be cancelled out. So you can imagine that all these terms have been cancelled out until here. So 98 times 99 times 100 minus 98 times 99 times 100 can also be cancelled out. So we only have one term remaining, which is 99 times 100 times 101, and we need to divide this by 3. So the answer is this term divided by 3, which is 333,300. We are asked to evaluate 1 times 4 plus 4 times 7 plus 7 times 10 plus ... plus 49 times 52 plus 52 times 55. First of all, we need to realize that each of these numbers are differed by 3. That means 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10, and so on. Then we are going to multiply each term of the expression by 9. So why do we choose the number 9? Let's take a look at the second term, 4 times 7. I want something like 1 times 4 times 7, so that it sort of can cancel out the previous term. I also want a term 4 times 7 times 10, so that it sort of cancel out the third term. Right now, I need a 1 in front of 4 times 7. I need a 10 after 4 times 7. So 10 minus 1 is 9. Therefore, I try to multiply each of the expressions by 9. So 1 times 4 times 9 is equal to 1 times 4 times 7 plus 2. So why do I break down 9 into 7 plus 2? The reason is I want 1 times 4 times 7. So right now I got the 1 times 4 times 7. And not to forget, I still have to add 1 times 2 times 4. I will also multiply the second term by 9. So right now I have 4 times 7 times 9. And then I will write 9 as 10 minus 1. So why do I need the 10? The reason is I want 4, 7, 10 as a sequence. So each successive term is differed from the previous one by 3. Then 9 is 10 minus 1. And not to forget to minus 1 times 4 times 7. So right now, I think you can see that these two terms can cancel out later. And let's work on the third term. So 7 times 10 times 9. So 7 times 10. And then the next thing, I need a 13. So why do I need a 13? It's because 7 plus 3 is 10. 10 plus 3 is 13. And why do I put down minus 4? It's because 9 is 13 minus 4. So right now I have 7 times 10 times 13 here, minus 4 times 7 times 10. Then I see that this term and this term will cancel out each other later. Let's get to the second last term, 49 times 52. We will also multiply this term by 9. But then I will change the 9 into 55 minus 46. So why 55? I think right now you know the answer. It's because 49 plus 3 is 52, 52 plus 3 is 55. That's why I need the 55. And 55 minus 46 is 9. So here I put down 46. So we have 49 times 52 times 55 minus 46 times 49 times 52. For the last term, 52 times 55, we also multiplied it by 9. Then we have 52 times 55 multiplied by 58 minus 49. The reason is 52 plus 3 is 55. 55 plus 3 is 58. And I need a 49 here is because 58 minus 49 is 9. So I expand the bracket and I have this thing. Remember, at the beginning, we want to evaluate this expression. But then I multiply each single term by 9. And the answer is here. So what do I have to do right now is I have to add all these terms. But at the end, I need to divide it by 9 so as to get this answer. So right now, I try to add all these terms. 1 times 4 times 7 can be cancelled out by this term. 4 times 7 times 10 can be cancelled out by this term. And so on. So the last term that I cancel is 49 times 52 times 55 minus 49 times 52 times 55. So there are only two terms remaining, 1 times 2 times 4 and 52 times 55 times 58. So I add them up together and divide by 9. And the answer is 18,432. We are asked to evaluate 1 times 3 plus 2 times 4 plus 3 times 5 plus 4 times 6 and so on, plus 98 times 100 plus 99 times 101. The first thing that I'm going to do is I'm going to split these expressions into two. I will organize them as 1 times 3 plus 3 times 5 until 99 times 101. So I will put all the odd terms in the left side of the expression. And then I will add all the even terms, that is 2 times 4 plus 4 times 6 and so on until 98 plus 100. Then I will use the skills that we learned in the previous two examples. So for every single term, I'm going to multiply it by 6 and then I add all these things up. At the end, I divide all of them by 6. So why do we multiply each term by 6? Let's take this term as an example. For the term 3 times 5, I would like to have 3 times 5 times 7, so that it could be cancelled out with the next term. And I also want a 1 times 3 times 5, so that it can cancel out with the previous term. I need a 7, I also need a 1. Then 7 minus 1 is 6. That is why for every single term, I'm going to multiply it by 6. So, for the first term, 1 times 3, I will multiply by 6. But what I want is indeed 5 because I want 1 times 3 times 5. So I break down the 6 into 5 plus 1. For the next term, 3 times 5, as mentioned before, I want a 7 and I want a 1. So I replace the 6 by 7 minus 1. So for the last term, It's quite obvious that I want 99, 101, and then I want a 103. So I put in 103 and then minus 97 because it will give me 6. I do the same for the even terms, so 2 times 4, I will multiply it by 6. And the next term, 4 times 6, I will multiply it by 6. But then I write this 6 as 8 minus 2, so that I will have 4 times 6 times 8. I will also have 2 times 4 times 6. For the last term here, 98 times 100, I will multiply it by 6, but I will write the 6 as 102 minus 96. So for all these terms, I add them up together and then I will divide them by 6. And the next step, I will apply distributive law to every single term. So here, I will have 1 times 1 times 3 plus 1 times 3 times 5 plus 3 times 5 times 7 minus 1 times 3 times 5 and so on. Then we have 99 times 101 times 103 minus 97 times 99 times 101 plus 2 times 4 times 6 plus 4 times 6 times 8 minus 2 times 4 times 6 and so on, plus 98 times 100 times 102 minus 96 times 98 times 100. And then the whole thing will be divided by 6. We see that this term cannot be cancelled out, but we can see that 1 times 3 times 5 can be cancelled by minus 1 times 3 times 5. So 3 times 5 times 7 can also be cancelled out. So we can expect that here there would be a 97 times 99 times 101 would also be cancelled out by minus 97 times 99 times 101. So from here to here, we will have 2 terms remaining. The first term is 1 times 1 times 3, and then the other term is 99 times 101 times 103. So we'll take a look at the even terms. So 2 times 4 times 6 will be cancelled by minus 2 times 4 times 6, and so on. So we can see that all these terms will be cancelled out except this one. So we will have plus 98 times 100 times 102. So the whole thing will be added together and then divided by 6. The answer is 338,250. In this example, we will do the addition from 1 to 100. So we have 1 plus 2 plus 3 and so on. We will work on this problem in the way the German mathematician Gauss did. He worked on the same problem when he was 10 years old. Instead of adding from 1 to 100, what he did is he added the same thing 2 times. So he added from 1 to 100 and then from 100 back to 1. The next step is he add 1 to 100, 2 to 99, 3 to 98, and then 98 to 3, 99 to 2, 100 to 1. So at the end, he got a lot of 101. So how many 101 are here? There are 100. Because there are 100 terms, right? So the answer is 10,100. But at the beginning, we only asked for one set from 1 to 100. So the answer to the original question is 50/50. In this example, we will talk about sum of squares. So we are asked to evaluate 1 times 1 plus 2 times 2 plus 3 times 3, and so on, until 99 times 99 plus 100 times 100. There are many formulas for the sum of squares. Today we will use n times n is equal to n minus 1 times n plus n. You will know the reason why we use this one very soon. So for the first term, 1 times 1 is 1. For the second term, 2 times 2, we will substitute 2 in this formula. So 2 minus 1 is 1 times 2 plus 2. And then we will substitute the third term in the formula. So n is 3. 3 minus 1 is 2 times 3 plus 3 here, and so on. And then we will substitute 99 into the formula. Then you have 99 minus 1, which is 98, times 99 plus 99. And then we will substitute 100 in this formula. Then you have 99 times 100 plus 100. So what we need to do right now is we need to add all these things. In the previous examples, we have already done 1 times 2 plus 2 times 3 and so on, plus 98 times 99 plus 99 times 100. We have also done the addition from 1 to 100. So the answer for these is 333,300, and the answer for these terms is 50/50. So adding them up is 338,350. This question makes use of the formulas we learned previously. So we are asked to evaluate 1 plus 1 plus 2 plus 1 plus 2 plus 3 and so on until the sum from 1 to 100. So we see that in each term is a sum from 1 to n. So we will make use of the formula sum is equal to the first term plus the last term times the number of terms divided by 2. So the first term 1, I will change it to 2 over 2. Because every subsequent terms I will have to divide it by 2. So here I will change the 1 into 2 over 2. And then for the 1 plus 2, I will apply to the formula. So the first term is 1, the last term is 2, the number of terms is 2, and divided by 2. And for the third term, the first term is 1, the last term is 3, and there are 3 terms, the whole thing divided by 2. For the last term, the first term is 1, the last term is 100, multiplied by 100 terms divided by 2. Right now I have the common denominator 2. I will add up the numerator 2 plus 1 plus 2 times 2, 1 plus 3 times 3, until 1 plus 100 times 100. And then I will expand the bracket by distributive law. So I will write 2 as 1 plus 1. And here I have 1 times 2 plus 2 times 2. And here for this term, I have 1 times 3 plus 3 times 3 and so on until the last term, 1 times 100 plus 100 times 100. If I group the odd terms and the even terms together, then I will have 1 plus 2 plus 3 until 100. And I also have plus 1 plus 2 times 2, which is 2 squared, plus 3 times 3, which is 3 squared, until 100 times 100, which is 100 squared. So I believe we have already done the sum from 1 to 100, which is 50/50. And we have also done the sum of squares, which is 338,350. So adding up and divided by 2, we have 171,700. We will work on this question. Evaluate 1 times 2 times 3 plus 2 times 3 times 4 plus 3 times 4 times 5 and so on until plus 98 times 99 times 100 plus 99 times 100 times 101. We can see that in each single term is the product of 3 consecutive numbers. So what we are going to do is we will multiply every single term by 4. So we will start with 1 times 2 times 3 times 4, which ends up to be 1 times 2 times 3 times 4. For the second term, 2 times 3 times 4, we will multiply it by 4. And then we change the 4 to 5 minus 1. Then we will have 2 times 3 times 4 times 5 minus 1 times 2 times 3 times 4 by the distributive law. So here we can see that if at the end we want to add things up, these two terms will be cancelled out. And for the next term, 3 times 4 times 5, I will also multiply it by 4. So we know that we need a 6 as well as a 2. Then we will change the 4 to 6 minus 2. By distributive law, we have 3 times 4 times 5 times 6 minus 2 times 3 times 4 times 5. And we can see that these two terms, when they add up, they will cancel out. So this process continues. And for the last second term, I will also multiply by 4. And I change the 4 into 101 minus 97 because I need both numbers. So by the distributive law, I have 98 times 99 times 100 times 101 minus 97 times 98 times 99 times 100. For the last term, I have 99 times 100 times 101 times 4, and I change the 4 into 102 minus 98. By distributive law, I have 99 times 100 times 101 times 102 minus 98 times 99 times 100 times 101. So we are supposed to add all these numbers up, and we can see that here these terms can be cancelled out. These two terms can also be cancelled out. Almost all the terms are cancelled out except this one. So we will divide this one by 4 because we multiply every single term by 4 at the beginning. And the answer is 25,497,450. In this example, we will find the sum of cubes. So we are asked to evaluate 1 cubed plus 2 cubed plus 3 cubes and so on until plus 99 cubed plus 100 cubes. There are many formulas for the sum of cubes. In this example, we will use this one. So n cubes is equal to n times n times n, which is also equal to n minus 1 times n plus 1 plus n. You will know why we choose this formula later. So 1 cube is 1, 2 cubed is equal to 2 times 2 times 2, which is equal to 2 minus 1, which is 1, times 2 times 2 plus 1, which is 3, plus 2. 3 cubes is equal to 3 times 3 times 3, which is equal to 3 minus 1, which is 2, times 3 plus 1, which is 4, plus 3. And so on. Then we have 99 cubes, which is 99 times 99 times 99, which is equal to 99 minus 1, which is 98, times 99 times 99 plus 1, which is 100, plus 99. For the last term, we have 100 cubes, which is 100 times 100 times 100, which is equal to 100 minus 1, which is 99, times 100, times 100 plus 1, which is 101, plus 100. So right now, we will add all these terms up, which is 1 times 2 times 3, plus 2 times 3 times 4, and so on, until add 98 times 99 times 100, plus 99 times 100 times 101. And then we will add 1 plus 2 plus 3 and so on until 99 plus 100. So we will add all these numbers. In the previous examples, we have already done this and this. So the answer is adding these two sum, which is 25,502,500.